Oh, we have
Okay.
participants, I believe.
Okay, so I get the notes that all the participants are there. Good morning, everyone. Thanks for joining our webinar. It's a joint webinar with Geo-Instruments and TotaLite on the topic of continuous monitoring for demanding environments. First of all, I would like to present the speakers to you, or actually, I want them to introduce themselves. But I'll start myself. I'm the managing director of TotaLite, and super happy to host this webinar to you. Anna?
Hello, everyone. Good morning. My name is Anna. I'm responsible for business development in TotaLite, mostly for the UK market. I believe there should be a lot of people here that we get connected before. Some of you will be new, but it's really exciting to be here and to introduce TotaLite and, of course, our wonderful client, Geo-Instruments, with Julien. Julien?
Good morning. Good to see you, everyone. I'm Julien, and I manage the operations for Geo-Instruments in France. So we specialize in I&M, structural, environmental, and geotechnical monitoring for civil engineering projects.
Yeah, thanks a lot. And for the audience, so we'll be presenting this webinar to you. If you have any questions, you can just drop them in the chat. At the end, we'll have a question to you, but then there's also a Q&A where we'll answer your questions. And we'll share with you the presentation afterwards. So you don't have to take screenshots all the time or write down everything you want to know. We'll share that information with you. Yeah, to get started, Julien.
Well, let's introduce the subject of A&M and automatic monitoring. This has become very more present in the past decades, and now this is expected by most big construction projects. We're expected to provide services with monitoring data, whether it's geotechnical, structural, and environmental monitoring. So there's a lot of data coming from different sources that we have to supply in a continuous manner on many projects. And the challenge has often been to justify the deployment of expensive monitoring solutions. This can lead to the installation of equipment that costs up to 50 or 60,000 euros or pounds, tens of thousands worth on site. And obviously, this is expensive equipment that needs to be maintained and deployed in a complicated environment. This is a challenge because you need to think about different aspects of the deployment. You have the fact that it's expensive equipment deployed in a difficult environment, as well as it's often complex to deploy this equipment. It's not a drop-in equipment you just install on site. You have several considerations in terms of each technology. For example, a total station, you need a line of sight to all of the monitoring prisms. You need to know in advance what will be the construction phases, so whether or not the building is going to rise up and block your line of sights, for example. You need to think about the other contractors that might interact with your equipment. Then, when it comes to the site infrastructure, you need to think about powering the device, keeping it protected, and ensure the telemetry is working. So you have a safe link from the site, which is not always a given. And this leads to the discussion that we often have with our clients with the fact that can we deploy a continuous and automatic monitoring solution, or do we stick to manual monitoring? Is it justified? So the question often revolves around the time that we have on site. Is it a 2-week monitoring job, or is it a 4 months or 4 years monitoring job? That's the challenge. So we have to weigh all of the pros and cons for the deployment of automatic monitoring solutions. And today we're trying to see if we can try to pick away at those constraints and see if there are more easier solutions to deploy. Thanks. What do clients need on site? So let's go over the 4 aspects that comes up every time we deploy those kind of systems. So the first one, obviously, in this case, we're talking about movement, but this is accuracy. Is the data going to be precise and accurate, which is often the focus, the first thing we talk about. Is it going to be a sub-millimeter, or is it going to be 1 centimeter accuracy? And that data needs to be validated and cross-checked with other monitoring solutions. So that's often the big focus of the deployment. And then there's other things, other aspects that were not there 20 years ago, but now it's becoming the standard, which is real-time availability with traditionally an online platform where the clients and all of the different parties involved can visualize and access the data, as well as instantaneous alerts, automatic reports, and feedback from the site as the monitoring occurs. Then what we try and push as always is reliability and uptime, so which leads us to choose one solution over another often. And what we want to avoid in a perfect world is a no data gap and uptime of the equipment. We can't have a downtime of the equipment. And lastly, the economic side of things, the main focus for our clients is to have a visibility over the solutions that we provide. Is it going to be a quick, easy, one-package solution with a simple pricing scheme, or is it going to be a tailored system that is custom to the actual site? And often it is that, because those systems are complicated and, like we said, have constraints. So we have to tailor them to each site. And a potential solution would be to have a drop-in solution that has less constraints and that is easier to deploy and thus easier to predict in the economics side of things for our clients. That's the target. Next slide, please.
Yeah, nice. Thanks, Julien, because actually addressing these challenges is at the core of TotaLite design. And so what is TotaLite? This is an image-based sensor for continuous remote displacement monitoring. TotaLite provides sub-millimeter accuracy that starts from 0.5 millimeters and actually quite comparable to total stations. TotaLite also delivers reliable 2D displacement data, capturing both horizontal and vertical movements. So actually the system can be set up within 1 hour. So once the sensor and up to 30 monitoring targets are installed in the field, you can simply go back to the office and start receiving real-time data. TotaLite doesn't require any calibrations, has really low power consumption, and you don't need to do regular on-site visits sometimes to confirm that nothing happened. Actually, at this point, most of the surveyors smile because this is kind of regular stuff. We can go to the next slide. Yeah, so actually TotaLite is not just a sensor, but also an ecosystem. We provide a TotaLite app that aims and helps to assist you during the installation on site, to do the proper installation and proper setup. And of course, TotaLite platform, which is super easy to use, user-friendly. And we also have API. That is why you can upload all the data from our platform to any software that you're working with and get used to, or just simply use our place where all the data will be collected. Next slide. Yeah, so long story short, TotaLite enables surveyors, civil engineers, and of course asset owners to keep assets safe while significantly reducing the time and cost associated with monitoring projects. About the cost, I think we're going to talk a little bit in the end of this presentation, and now I think we can move to the case study itself.
Okay, let me take you to a journey in the southeast of France, where right now we have the ITER project, which is the biggest nuclear fusion research project in the world, with dozens of countries involved. And the Mirabeau project is a bit involved with that, because it's regarding to the roads that the convoy for this project require. These convoys are lorries that can reach up to, I read somewhere, 800 tons. So those roads need to be rated to heavier loads than usual. And that road, unfortunately, was crossing a tunnel boring machine project that was aimed at redirecting gas mains under the river Durance. So the TBM went under the river, and just before it reached the exit shaft that we see on the picture here, about 150 meters away, at a pace of 30 meters every day, the client was asked by the authorities to ensure that the road would stay structurally sound and the geometry would stick within accept limits that were allowed. So we were asked just a couple of weeks before the TBM was crossing under the road to provide a continuous monitoring solution. So we thought about it, and we thought that the automatic total station was the best solution to provide 3D monitoring displacement for this. So this is what we implemented on site. Next slide, please. This is the total station that was deployed early December 2025, in just over a day. The client prepared a concrete base for us. We came in with a metal post, which gave us a good monitoring point of view. On the road that we see on the top picture on the left there, we deployed 9 road monitoring prisms, and those were shot by the total station, as well as 8 references installed throughout the site in very stable positions. So it took us roughly a day to deploy this, the total station, the monitoring equipment, the energy to bring to the data logging side of things, and the telemetry to transmit the data and recording the positions. And then towards the end of the day, we chose to deploy the TotaLite station, which was new to us at the time. This is our first deployment, and it literally was just a matter of setting up the sensor on the steel column with the bracket and powering it. With the app we used to make sure that the field of view of the camera was aimed at all 9 road monitoring prisms. We were able to shoot as well 3 reference points within the same view, within the horizontal field of view, and within the range limit. And then on site, we observed, this is when the reality check came in. We faced very tough conditions. I'm talking about obviously very cold in December, heavy rain periods, fog, humidity that was stuck at 99 or 100% every day. This was pretty challenging. Also, the slope of the road led us to face the monitoring prisms facing up, so the water would pool in the shooting area of the road prism. So this led to gaps, but fortunately this was compatible with the site requirements. So although the data was intermittent, we still managed to get a few hundred readings a day, which was satisfactory in the end. So now let's look at on the next slide what came up. Just to summarize the deployment, like I said, it was very easy to deploy the TotaLite sensor. I remember I was there was just the 2 of us, and the TotaLite sensor was deployed in just over an hour really. We spent another 30 minutes checking the data was coming into the app and in the interface, and all 9 prisms plus the 3 references were being shot at a 5-minute interval. So we decided this was satisfactory, and then we moved on to analyzing the data remotely, and this proved to be very satisfactory. This is the data that came up. As you can see on this graph, the first thing you will all notice is that there is not much movement that occurred, which was good news for the client. We can see that in the first week or so, which is very shortly after installation, all of the movement occurred, which was from 1.5 for this sensor up to 2.2 millimeters for another. It was very limited and within spec. So this was already a success. And we can see on this graph, obviously, there are several gaps in data, some peaks here and there because of the water interacting with the laser sites of the ATS. But in blue, we have the ATS readings, and in purple, we have the TotaLite readings. So what are the two main things we can see? Well, we can see it's all overlapping perfectly throughout the monitoring period, which suggests that the readings that we get are very accurate. And because we already have a good ATS installation with very stable and good quality, the readings processing quality results were all good, gave us the insurance that we had an accurate system. And because the TotaLite sensor is providing readings that are overlapping with that, we can conclude that the TotaLite solution is performing just as well in those conditions, which are really tough. We can see that both systems demonstrate a limited amount of fluctuations, which suggests that on top of accuracy, we have precision. And yeah, I will conclude that this validates that this solution for us in those conditions, obviously we only focused on the settlement in that case. We did not focus on planimetric movements on X and Y, but in those conditions with those constraints and those parameters on site, the result is there. So we have the same engineering grade results, but with potentially more scalable and cost-effective approach for future sites. So this is very exciting and good news for us and all of the industry, I believe. Next slide, I think.
Yeah, super exciting. So I'm super happy that TotaLite proved to meet the spec and also has proven to be so easy to install and so quickly. So this bold claim of continuous monitoring is more feasible than ever is what we aim for as TotaLite. We know that continuous monitoring is already feasible before TotaLite existed, but the whole point of it, making it super accessible, making it scalable, is the thing that we focus on. And this is one project where it, in harsh conditions was actually shown. So we're super happy with this project and these results. And in a broader sense, this is not the only project that we tested it on. In the meantime, we have shipped over 120 systems, and we have more than 100 different assets that we have monitored, where we see the same results. So we have proven it not only in the laboratory and in our own nicely conditioned environment, but also in those harsh field environment. And that was a long journey, because the first generation, for those who still remember that, was a different shape of TotaLite. And what we learned there is that it was not robust at all in outdoors. So it was not robust for rain, dust. And now with the new TotaLite 2, with the new housing, it has a wiper that cleans the shield, that cleans the lens, and a small brush on the outside that also takes away the spider webs that we were confronted with in the past. And this has proven to be super robust and in that sense proven. So super happy with those cases and looking forward to build a lot more cases. But this is a real tough one that improved its performance.
Yeah. Oh, this is my favorite part about comparing the market and comparing TotaLite to traditional surveying tools. We do understand that we're working in a very conservative industry and at very conservative market, where like new technologies like TotaLite can be considered as something, well, in the beginning, of course, most of our clients, first of all, prefer to compare TotaLite with existing methods, mostly total stations. And of course, like really cautious about trying something new. But we need to share why it makes sense if, for example, you have in your workflow among your requests monitoring and deformation monitoring and movement monitoring. So from the standpoint of CapEx, if let's compare TotaLite to total stations. So total stations is super expensive, but it's not enough just to buy total stations. You need to provide service and a lot of like operational costs, mostly labor costs that requires to work with the system. TotaLite is really little labor, no specific training required to work with the system. So even the junior surveyor can take TotaLite and just go to the field and install it. Another like significant difference between total stations, because most of all, even though TotaLite is not a total station, but sometimes people compare, is that total station provide like in one measuring cycle, 1 point in a time by laser point. While TotaLite can take a snapshot of several targets, as I mentioned before, around 30, which in some cases is can be crucial. And again, labor intense. Total stations require like special knowledge, a lot of time to work with, especially if you're working on the project. When you use manual total station, you need to bring it, to install it and everything, while TotaLite you just install in the field, go back to the office and have the whole data in your laptop. We can go to the next slide. Yeah, so some more arguments while this matters. As we discussed in the beginning, and also Julien mentioned that sometimes the price can be the price and the cost of the project can be like the most important if you're gonna win this project or not. Based on our experience and on all the projects that we have before, as Epco mentioned, we sold more than 100 TotaLites over the past period. We noticed that with some projects and with some clients, we helped them to reduce the cost by up to 40%, which I think is amazing. As we discussed before, TotaLite is not just a sensor, but the platform. So you have everything in one place or integrated into your existing workflows. What is also important, TotaLite was validated by some universities, including TU Graz in Austria, that really showed that TotaLite does it work and really can provide the accuracy, reliability, and everything. You don't need a lot of resources to work with TotaLite. So that is just, you buy the system, it does its work. And of course, for some companies, I know that not all of you provide monitoring services, and sometimes you're thinking about whether it makes sense to step into this market. So TotaLite can be a really good door opener with very low entering price, to try something new and include monitoring into your workflow into the scope of services that you provide. We can go to the next slide.
Yeah, maybe on a bit broader perspective, why does this matter for the industry? We see all around the world that infrastructure is aging. So there's, whether it's railway tracks on this picture or bridges, or a lot is being built after the Second World War, getting at the end of life is getting critical. And we see all around the world that this increases the challenge. And in some countries, we just don't have enough either money or staff to actually do all those projects. And also on the construction side, we see that construction projects are getting more complex. So there's more built environment. So if you do a construction next to a metro line, you don't want a metro line that is in operations, you don't want to have moving. It's getting more complex in that sense, but there's also more and more regulation coming up. And at the same time, we see that our clients and asset owners, civil engineers are sometimes struggling to find enough staff to actually fulfill those projects. So for us, that is on a broader scale important to bring something that is efficient, easy to deploy and operate, and in that sense makes it scalable, enables the industry to do more projects with the same staff. So that is our view, and we're trying to underpin that with these case studies. And for this webinar, I want to give the last word to our customer, Julien, or at least have it the quote, your quote on the on the screen, Julien.
Thank you for letting me share my experience.
Yeah, thanks a lot for listening. But now we come to Q&A, and we actually want to kick off the Q&A with one question that we have to you, which you can answer in the chat. Let me throw that question in the chat. And I see that there are already many questions popped in there. So we'll come to those. So what is the biggest barrier today preventing you from scaling continuous monitoring? Something that we are curious about.
We've got a question. Who installs and manages the sensor? Does it require a specialist? The question from Brian from Birmingham. Thank you for your question. Actually, you can. In most of the cases, our customers install the sensor themselves. What we do, we support you during the whole process. So we do online onboarding. Also, every customer has a customer success manager that you can address all the issues and questions that you have about TotaLite. But as we said, TotaLite is really plug and play solution. So you just read manual, or we give you some advice what is the best way to do setup, and then you just install it. And you really don't require to be a specialist or have the specialist on board. In some cases, when the project is very serious, for example, like you're from UK with Network Railway and it requires special attention, we can also go back to your place and help with installation so everything can go smoothly.
Got it. We also have an older question from John Daniels. What is the continuous battery runtime of this device? Anna, are you going to answer that one?
Yes, I have this during all presentations that we have. TotaLite doesn't have a battery, so it always requires an external source of power. But TotaLite is really low consumption. So, for example, if you have the biggest frequency of measurement, that is every 5 minutes, TotaLite consumes only 2.7 watts per hour. So it can be easily connected with a solar panel, especially during the summertime. But answering your question, TotaLite always requires an external source of power. It doesn't have battery.
Yeah, correct. Then a question from Pavel. Can TotaLite replace an ATS entirely, or is it always a complementary solution?
Again, me? Oh my God, I'm the star of this webinar. By the way, Julien, this is something we discussed a couple of days before, how you're planning to integrate TotaLite in other projects. Maybe you can share your experience, whether it can be substituted.
One TotaLite sensor does not replace an ATS out of the box. You need to consider for each automatic monitoring solution, you need to consider their own limitations. So if you know the limitations of the ATS and discover the limitations of the TotaLite sensor, you can see and cross-check which projects match. So for example, in this case study, we saw that for our client, the sole focus was the vertical movement. So the limitation of the TotaLite sensor is that it monitors 2D movement, which is displacement in the picture plane. so perpendicular to the line of sight. So, and vertical movement. But vertical movement is the same in no matter the plane you're looking at. So for every project where you only need vertical movement and you can shoot the prisms, I say shoot, sorry, I see and target the prisms within the horizontal field of view of the sensor. If those conditions are met, then, like in my case, it can replace an ATS in that application. So it needs to be considered on a project-to-project basis, really. And this leads us to another question, if you don't mind. I saw a question I wanted to comment on.
Maybe
It said,
Julien, before going to the next question, one thing that I want to add to this. So I think there are indeed projects. There are many projects where it can replace an ATS completely, and you can just have the TotaLite there. But like Julien said, there are some conditions. If there's requested, for instance, a distance measurement, then we cannot do that with TotaLite. So there are, or if it's outside of the field of view, your targets, and you either need a second TotaLite or you have to do it differently. So there are conditions where it doesn't fit. But I think in this case with Mirabeau project, it could have been just the TotaLite. It's that this was your first project with it, but in this case, it could have been just the TotaLite, right?
Yeah. We deployed both solutions because we wanted to provide the service to the client and give them the insurance that we had a trusted and verified solution. So we deployed both solutions to see how they would perform against each other. And those tough conditions brought an extra load to the challenge, but they both came out on top. That was expected for the ATS, and it was confirmed for the TotaLite sensor.
Yeah, great. So sorry that I interrupted you. Let's jump
to the
one.
No worries.
You wanted to
there
pick
was a question about what is the smallest kind of project this is justified. I wanted to say that there are definitely projects. I can't give too many details because obviously it depends on the project and it is a commercial discussion. But there are definitely projects that we are not turning down, but we can't do for a total station. If the client comes to us and say, I need it yesterday for 2 days, this is hardly a justification for a total station. When if they say, do you have a total state sensor? It matches the limitations of the sensor, matches what we need. Does it work? Well, if you are not far away, you can just go there and install it, and within the hour, the sensor potentially is set up. So there are definitely projects that we can't answer with the ATS that could be answered with the TotaLite sensor. It's another weapon to our arsenal, if I may say.
Yeah,
this is a good one.
Thanks.
Well, I also would like to add a small comment to Julien's answer and actually answer the second question. What is the price per sensor, per project, per subscription? This is a question from David from United States. So, of course, projects, as Julien mentioned, when you need to do like really short-term monitoring and very fast, for example, and in some projects, TotaLite, it makes sense to install it when the project is super price sensitive and it doesn't require that measurement. So if 2D will be enough and you need to bid against somebody from the standpoint of price, TotaLite is a really go-to solution. And about the price, Epco, I think we can announce the price for the sensor. It is open information. So the price for the sensor is 2,900 euro. So this is 2,900 euros. This is for sensor. And subscription starts from 120 euros per month for one sensor. Within this subscription, you can monitor as many targets as you would like and install at any projects that you like. So you're paying for one sensor, one subscription. Another really important point, because we're trying to not just doing business, but to be partners for our clients. And we understand that sometimes you have job for TotaLite, sometimes you don't, for example, for a couple of months. During this period, you can easily pause the subscription and activate it only when you have the project. So you don't need to pay for TotaLite in case if it doesn't work.
Yeah, so it's basically like your Netflix subscription. You give us a heads up and that you want to deactivate for next month, and we'll deactivate them. You don't pay for it. The subscription price depends per region.
And depends on the region, yeah.
So this is roughly the average, and it depends on the region because of the connectivity. So there's an onboard SIM card, which uploads the data directly to the cloud, so you don't need any additional gateways. And if you don't have coverage, so if there's no internet connection directly, then we can always, for instance, in a tunnel, we can always fall back on an Ethernet solution that is cabled to a router. But that's why the subscription depends a little bit on the region and also on the volume. If you have 50 TotaLite sensors running in parallel over the different projects, you get discounted for that number. So there's volume brackets in that pricing.
Yeah, we get really nice question. What does monitoring dashboard look like for client versus engineer? So we also thought about this stuff, and within TotaLite platform, you have you can provide special link for your clients where they're gonna see the same data as you see, but they don't have admin rights and they can't do any changes. So actually the dashboard, as for engineers, as for your clients, will be the same, the overview, but with limited rights to change something and to do some corrections. So it's really convenient. You can just share TotaLite platform access to your clients.
Yeah. And linked to that, we also have this other question. What is the data output format? Can it feed directly into existing monitoring platforms? So basically in the TotaLite dashboard itself, you can see all the vertical displacement, the horizontal displacement, inter-target displacement, if you talk about tunnel convergence, for instance, and you can do a lot of troubleshooting. But there is an API that you can link your own platform to, and then the data is automatically real-time transferred to your platform, the platform of your choice. If you want, you can also export it in a JSON or a CSV, but that's more laborious, but that is possible. What you advise for a project covers a wide area, for instance, structures to monitor cover a wide area, for example, run of a river hydropower project where structures are spread over a wide area. So it really depends on the distances. TotaLite is proven 100% up to 70 meters range. In some ideal conditions, we can even go to 100-meter range. And it has a field of view, so it needs to be installed rigidly. And has a field of view of 60 degrees horizontally and 45 degrees vertically. So basically that's what it can capture. And then it depends if it's a super wide area, hydro dam, or landslides over multiple hundreds of meters. Then typically you need quite some TotaLite sensors to monitor that, and then other solutions can be better solutions. If it's in that wide area, a specific smaller area that you want to monitor within that range of 70 meters and that field of view, then TotaLite can definitely do that.
So I also always like to add some comments to all
this. Go ahead.
Sorry. So for example, I noticed from the work with my clients, sometimes, of course, one TotaLite, so this is really compact sensor for really specific, of course, it has its own limitations. But for example, if you have big project and you need to monitor really wide range of sections, you can easily install several TotaLites and you can have it on the platform. This is actually what our clients do. I can say that hardly ever somebody buys just one TotaLite. In most cases, our customers own around 3 TotaLites, because in this case, it adds flexibility from the standpoint of how many sections they can measure, and it really gives variations how the setup can be done. So you can use several TotaLites within one project.
Yeah.
To help with this, if you, I don't know if someone who doesn't own a TotaLite sensor can, but if you don't, on the app, on the TotaLite app, you can use the viewer to visualize on site with your camera on your phone what does a 60 horizontal field of view and 45 vertical field of view means. This helps a lot on site. So I don't know if you can do it without the TotaLite subscription, but it helps you design and come up with a solution.
You can't. You need to pay for subscription.
Well, the app is pretty good then.
Yeah, thank you.
Yeah, and I don't see further questions, but I do see an answer to the question that we posted on what are the barriers today to do continuous, or that prevent for continuous monitoring. Thanks for asking that. Sorry for answering that. The answer being mainly the confidence that continuous monitoring is reliable and cost effective. Yeah, thanks. So I think that also matches very well with the end client requirements in this case study that Julien explained at the beginning. But I think in any project, it is clear there are certain specifications that need to be met in terms of deformation, in accuracy, precision, and the solution must answer that in a reliable manner. You need to be able to trust the system that it's delivering those specifications. But your answer also underpins that cost effectiveness is important one. Yeah, which is one of the things that we're focusing on. Yeah, thanks a lot for giving that answer.
We've got a question from Michael. Will some prisms be used as reference points to have control? This is really good question from the standpoint of like setup that should be done. So as Epco mentioned, TotaLite should be installed rigidly, and you can have, I call it, like two scenarios how the prisms can be located. The first scenario, you need to have at least one, better two reference points that also will be stable, because the rest of the targets, their movements will be measured relatively to these 2 points. Another scenario, if, for example, you work on tunnel projects and you need to measure convergence, you can measure TotaLite can measure inter-target distance, so between two targets. So in this case, we don't need reference point, but still it's better just to have double control, to have at least one. But in case if it's not possible, we can measure inter-target distance without reference point.
Yeah, and the two one and two reference points, that we use that for the horizontal displacement. Vertical displacement you can do even without reference points, because there is an onboard accelerometer that compensates for roll and pitch. So it's actually already leveling that information. So if you're purely looking at settlement, so only the vertical displacement, you can even do it without reference points as well.
Okay.
Then,
we have really nice.
When using multiple TotaLite sensors, do they have the capability to interpolate into a network? From Stephen.
Daisy chain.
So this one is not in the TotaLite software yet. So we have received this question more often, and we do have it on the roadmap that you can actually do so. But at this moment, TotaLite itself does not facilitate that. What we see customers doing is that on the day of installation, they install the prisms and the TotaLites that they want to see in their network. And they, on the installation day, they come with a total station, and they do a manual survey of where the TotaLites are exactly and where the prisms are, and make the network on their end. And if needed, every now and then, once half a year or whatever the frequency, if they really want to validate it during the project, they come in to revalidate it with the total station. Just to make sure that it's verified data. But that's how they typically do it. Often just only at the installation. and then they make the network on their own side.
We have a question from Seth. How far in advance do you need to plan a TotaLite deployment relative to TBM arrival? I don't know what is TBM arrival.
The tunnel boring machine.
Okay, so this is to Julien.
As soon as possible, really. Not 3 weeks before it arrives. This was not, in that case, a huge focus, because no one was really concerned the road would move. It was more of a contractual obligation that the client had to fulfill. But whoever's responsible for guaranteeing the integrity of the road is responsible for bringing in the monitoring solution, really. So how far in advance are you responsible for it? If you are, you need to plan for it, I would say. So as soon as possible. But in that case, well, which is probably the worst case, I can say, you can deploy the TotaLite station just an hour in advance, really, if you feel like it. But it's probably best to do it a few weeks in advance to get baseline monitoring data. Really, that's what I would say.
This is good one, especially, yes, to create baseline to understand which will be the starting point for measurement. Julien, I think this question is also for you because it is from France. Yeah, here it is. For my geospatial client, how does the sensor handles condensation and lens fogging in high humidity environments?
Well, like we saw in the presentation, the TotaLite sensor has a wiper. So it's just an electric wiper that goes over the lens before and after, I believe, at least once. I think it's just before and after the reading. So it doesn't take a lot of energy. It just makes a very gentle whirring noise, and the wiper and the lens is always clean and ready to go. It's the prisms you need to make sure they're clean and not full of rain or fog. So the lens it's a non-issue. This, I believe, this was a development for the version 2 over the version 1. But now I have full confidence. Having gone through those tough conditions, I've got full confidence that it can handle heavy rain and difficult weather conditions. We need to see on conditions with dust how it performs, but I believe it would work just as well. So yeah, the wiper works well.
I can tell even more. This year, when the final version was launched to the market, we also had projects during this winter in Canada and Norway, where it was around from -16 to -20 degrees and heavy snow, and TotaLite also worked well. Frankly speaking, we were a bit concerned because we didn't try it in this kind of tough conditions, and we were super happy, as well as the client, how the sensor itself behaves. So the only issue was the same as Julien mentioned, only with the prisms, but that will be with any system that requires like glass prisms in the whole setup.
And the TotaLite, the shield with the wiper is designed as such that if it's not making a measurement, it's actually closed. So if there's no measurement, there's no rain and dust and etc. coming on the front glass at all. And then if the measurement will be taken, it takes one turn to clean it. It takes a measurement, it takes another turn, and then it closes again. So there's less chance to get polluted or wet, and then it cleans it when the measurement is taken. So that's automatically aligned with the measurement frequency that you choose.
We have a comment from Alex, I suppose. In the netherworld, we're using electric peeling equipment.
And what, Alex, I'm not sure yet what the actual question is with using electric piling equipment as an alternative to TotaLite, or is there a specific question to TotaLite?
I believe this for the working conditions, maybe electric piling maybe generates dust.
Oh, good question. How is internet connectivity managed to enable real-time data transmission in remote areas? So TotaLite is equipped with internal eSIM card. So in case in the region, if in the region there is an LTM coverage, TotaLite gonna work perfectly. In case if it is, for example, a tunnel, when it is always an issue with the connectivity, TotaLite has special port, so you can plug in Ethernet cable. And in this case, you don't need your SIM or mobile network, and data will be transmitted through Ethernet cable, by means of Ethernet cable.
Yeah. In view of time, I think we can do one other question, and then we're rounding off.
We have 8 minutes, and questions keep on going. Let's answer as many as possible. We have another question.
Yeah, you're right.
Any limitations on field of view and planimetric measurement, and how do you work around them?
Yeah,
Well,
so
go ahead.
Yeah, so basically, the limitation as such is that it's a 45-degree vertical field of view and a 60-degree horizontal. So it's not turning around. It's you install it in a fixed manner, and that's what it sees. So that you need to be careful when you select it or when you install it. You need to be careful that all your targets are in that field of view. So that's definitely one thing that you want to do, and that's where also the TotaLite app comes in, so that you can actually have the angle of view that the TotaLite sensor will see. You can make a picture, you can look at it and see if all your targets are in view. So that is one important one to how you work around it. On the planimetric measurement, I think Julien, you have the real-time experience in how to work around that one.
The TotaLite sensor, you need to realize that it takes a picture in a plane that's perpendicular to the line of sight from the sensor to the target. So once you understand that the displacement is in that plane. So if the sensor is not oriented right, you will get displacement from a plane that's slightly different from the expected direction movement. So now you're tapping in the expertise of the I&M company that will implement a solution. So like Anna said, I think the main solution is to install more TotaLite sensors in specific orientations that need to be tailored to the project in question, really. And software implementation, that's a subject. If you are measuring displacement in a specific plane, but you want it into another plane, you need to project it. So that's down to surveyor expertise, really.
Yeah, thanks.
Thanks. I think we don't have any questions. I suppose we have like the best audience for this webinar because 5 minutes left and the questions have stopped. Really time-wise.
No, it's really nice to have had so many questions. We thought that we would have a Q&A of 15 minutes, and then, but I'm super happy with the interactivity. If there are any questions that are popping up in the coming days or weeks, feel free to reach out to us. As said, we'll share our information, not only mine, which you now currently see on the slide, but also from Anna, from Julien. You get the slides. And as said, thanks a lot for your time, your attention, your questions, and if anything pops up in the coming weeks, feel free to reach out to us. Then I wish you successful monitoring.
Thank you.
Thank you everyone for joining. It was really a pleasure. Hope it was really useful also for you. Thank you, guys.
Have a nice day.